We're going to start our first example of completing the square to solve. Now recall where we would like to probably go. We would like to create a perfect square factor on one side and a constant on the other. That is the ultimate goal. So really what we would like to do is create a perfect square, and we can do that by completing the square. So let us do that. So here's my equation, x squared minus 4x is equal to 5. And I am going to create a perfect square factor. How do we do that? By complete the square. So if I take a look at the left-hand side of the equation, is my expression on the left-hand side ready to complete the square? Well, in fact, the coefficient in front of the x squared is 1, so that's always a good sight, or a good sign. We have x squared, and we also have the term of x to the power of 1. So the game is on. What constant am I going to add here? Well, I'm going to add 4. And I'm going to add 4 to the left-hand side, and now it's a perfect square trinomial. So, but if I add 4 to one side of an equation, I'm going to keep it in balance. How am I going to do that? I'm going to add 4 to the other side of the equation. So on the left-hand side, I have, if I factor x squared minus 4x plus 4, it factors into x minus 2 squared. On the right-hand side, 5 plus 4 is 9. I've been here before. I have a perfect square factor on one side and a constant on the other. The next thing I'm going to do is I'm going to take the square root of both sides. And when I take the square root, I'm going to consider both positive and negative roots. So x minus 2 is equal to plus or minus the square root of 9. So I'm just going to clean this up ever so slightly. Square root of 9 is 3. So and now I'm going to add 2 to both sides. And there's my solution right here. My x1 would be, my first solution would be 2 plus 3. My second solution would be 2 minus 3. So the first solution is 5, the second solution is negative 1. So therefore, we have solutions at x is equal to negative 1 and 5. Pivotal to completing the square, you need to put your algebraic expression, everything with a variable to the left-hand side, your constant to the right. Furthermore, the coefficient in front of the x squared needs to be 1 in order to complete the square. Let's move on to the next example. So we're going to complete the square to solve. And on the left-hand side, it's x squared minus 6x plus 9. So what I could do is I'm going to move the constant over to the right. Everything with a variable is on the left-hand side. My coefficient in front of the x is 1. This is ready to complete the square. So I'm just going to take my expression. I'm going to complete the square. What constant must I add to complete the square? It's going to be 9. If I add 9 to the left-hand side, I wish to keep this in balance. So I'm going to add 9 to the right-hand side. That's how I'm going to balance it this time. Now, the left-hand side is a perfect square. How do I know that? Well, I just completed the square. And when I factored it, it's x minus 3. On the right-hand side, minus 9 plus 9 is equal to 0. So I have x minus 3 squared is equal to 0. I'm going to take the square root of both sides. When I take the square root, I'm going to consider both positive and negative roots. So the square root of x minus 3 squared is simply x minus 3. And now this is x minus 3 is equal to plus or minus 0, which just is 0. So we have x minus 3 is equal to 0, so my solution exists at x is equal to 3. All right. I fell asleep there for a while. One really great thing about math is those who maybe take an extra second to look at a question, come to a great thought, let their minds be open, sometimes they see everything. So when I'm taking a look at this expression, and I notice that the left-hand side is actually a perfect square already. And if you're able to recognize that, you actually take out much of the hard work out of the whole entire question, and you come to the same result. All right. Now this next question, I don't know if I'm a fan of it, but it shows you something incredibly important, I think. Often when we forget about the strengths about dealing with an equation, I really enjoy equations because it allows me some freedom that functions and expressions do not. For example, I can divide both left-hand and right-hand side by an amount. I can multiply both the left-hand side and right-hand side. Whereas a function, you really can't do that. You're really much more limited. I'm going to consider this equation. Fair enough. I've considered it. Now we need to play the completing the square game. The variables are on one side, but what we see is that the coefficient in front of the x squared is not 1. In fact, it's 2. So how do we make it 1? Well, think about this. Here's my solution. It's not a great solution. It may not even be the best, but here's what I would do. Take a look, and I notice that all the coefficients in here are divisible by 2. So if I divide both left-hand and right-hand side of the equation by 2, I end up with x squared minus 4x is equal to 5. Now I've solved that. If you look, that was the example 2 examples ago. I've been here. I can do this. So that's how we simply do this to get rid of that coefficient of a. You can divide by the constant. However, I know that some of you would like to travel a different path. You're probably looking at 2x squared minus 8x is equal to 10. I know you would probably like to factor out that 2, and there's nothing wrong with factoring out the 2. And then maybe at this point, you would divide both sides by 2. And it might look like this. And that's all good and fine. Notice that we end up in the same spot. As long as your algebra is good, you're keeping things in balance, and you know where you're going, you'll end up in the same place. The reason why I'm not going to complete the question is because we've seen this exact question before.